How's it going, 12s? I'm going to be going through exercise 5.8. In this video, I will be going through numbers 5 and 6. Okay, so before I get onto it, I'm going to show you guys, I'm going to be using these formulas quite a lot in this exercise. So, for example, sine 2 theta is equal to 2 sine theta cos theta. That's your sine double angle. Your cos double angle can be one of three things. It can be this cos squared theta minus sine squared theta, or it can be 2 cos squared theta minus 1, or it could be 1 minus 2 sine squared theta. Other things I'm going to be using is your square identity, sine squared theta plus cos squared theta equals 1, and then just your tan identity, which is tan theta is equal to sine over cos. Okay, so I'm going to be referring back to these quite a bit. This one, and this one are given on your formula sheet. Okay, this last one is not. You just need to know that one off by heart. Okay, so question 5 is saying determine 2 sine 25 cos 25 minus 2 cos 25, plus 2 cos 25 sine 25. Okay, all over cos 14. All right, so as you guys can see, these things are exactly the same. We've got a sine 25 cos 25, sine 25 cos 25. Now, it doesn't make a difference that they are swapped around, okay? Because, for example, 2 times 3 is exactly the same as 3 times 2. Okay, so what I'm going to do is, yes, I could add them together, but just for now, I'm going to treat them as 2 separate double angles. So, for example, you can see from here, our sine double angle is 2 sine theta cos theta. So that's basically what we've got here, 2 sine theta cos theta. So I'm going to treat this as one double angle. And the other one I'm going to treat as a double angle is this one over here. Again, we've got that situation, 2 sine theta cos theta, 2 sine theta cos theta. So that can be my second double angle. And what I'm going to do is I'm just going to reverse it back to this one over here. So it becomes sine 2 times that angle. So the blue one will become sine 2 times 25. Plus the orange one will become sine 2 times 25. All over cos 40. All right, so this I can just simplify now to be sine 50. The same goes for this one, sine 50 over cos 40. I'm going to get the like terms together and just add them together. So we get 2 sine 50, because sine 50 plus sine 50 gives us 2 of them, all over cos 40. Right. Now, grade 12s, whenever you see a situation like this, I'm always looking at the angles, okay? So this 50 and this 40, you can see that they add up to 90 degrees. All right, so we can see that this 50 plus the 40 will give us 90 degrees. Now, as soon as something adds up to 92 angles, they're complementary. So we can use what I call COCO. Okay, in other words, I can change either one of these to the other ones. For example, I can change this to cos 40 because it adds up to 90, or I can change this to sine 50. What I'm going to do is I'm just going to change the top one. Doesn't make a difference which one I change. So what I'm going to do is I'm going to say here that 90 minus 50 will give me that 40 degrees. But as soon as I do this 90 minus, this sign will change to a cos. All over cos 40. Okay, so at the top we get cos 90 minus 50 is 40 degrees, all over cos 40. Now these can cancel, and you're left with the final answer of 2. Okay, so grade 12s, always watch out for that situation where you can change the one into the other one. It's a dead giveaway. If the angles add up to 90, then you can use COCO. All right. All right, the next one I'm going to be going through is question 6. Okay, so question 6 we've got here. And it's 2 parts. Question 6a, we've got, it says, prove that sine 2x plus 2 sine squared 45 minus x equals 1. So we need to prove this. So whenever they ask you to prove something, it's a left-hand side, right-hand situation. So on the left-hand side, we have this sine 2x plus 2 sine squared 45 degrees minus x. And on the right-hand side, we have 1. Okay, so the first thing I'm going to do is I'm going to expand my sine double angle, which is this one over here. Okay, so we get 2 sine x cos x. Now, this one over here, this is a compound angle, okay? Those compound angle formulas will be given on your formula sheet, so you don't have to worry about them. But the problem is we don't have anything about a squared or a sine squared. So what I'm going to do is I'm just going to rewrite this in a way that we can use our compound formula. So we get sine 45 minus x squared. This is exactly the same thing, grade 12. So I can put the squared over there, or I can put the squared outside. The reason why I'm putting it on the outside is now I can use my compound formula over here. And if I expand that, I will get 2 sine x cos x plus 2 multiplied by, now I'm just going to expand this, so it becomes sine 45 cos x minus cos 45 sine x. And that is all squared. Okay. Your 45 and your 45 are special angles, so I can work those out. Now guys, you can use the fan method, the table method, the triangle method, whatever method suits, you can sort these out. Just remember with these type of questions, they'll say without the use of a calculator. Okay, right, so this will stay as 2 sine x cos x plus 2 sine 45 is going to be root 2 over 2 cos x minus cos 45 is also root 2 over 2 sine x. Okay, now just remember what the squared means. The squared means that we have 2 of these brackets, so we've got another root 2 over 2 cos x minus root 2 over 2 sine x. Okay. When we've got a binomial with a binomial like that, you're just going to FOIL it. So we get 2 sine x cos x plus 2. If we do the firsts, the root 2 times the root 2 is just going to give us 2 over 2 times 2 is 4. Now, don't worry about simplifying this just yet, guys. I will do that in another step, okay? Then cos times cos is cos squared x. Then we do the outers. Again, that's going to give us 2 over 4. And it's minus. And it's sin x cos x. Then if we do the inners, again, it's going to be minus. And it's going to be 2 over 4. Sin x cos x. Then if we do the lasts, we're going to get plus 2 over 4 sine squared x. Okay. Now I'm just going to simplify things inside that bracket. So we get 2 sine x cos x plus 2. That'll give us a half cos squared x. Then this minus this, so it's basically a half minus a half will give us 1 sin x cos x. Okay, and then the last one will just give us plus a half sine squared x. Okay, guys, so as you can see, these things can get quite messy, if I can call it that. Just keep to the basics and just work with it step by step by step, and you'll see it'll come out to a nice solution like this. Okay, the next thing I'm going to do is just multiply the 2 inside the bracket here. So we get 2 sin x cos x. That'll just give us cos squared x. That'll give us minus 2 sin x cos x. And then that and that will just give us plus sine squared x. All right, so as you can see, this minus 2 sin x cos x will cancel with that 2 sin x cos x. Then I've got this cos squared x plus sine squared x. That is our square identity. Sine squared of an angle plus cos squared of an angle equals 1. So those two will give us 1, which is equal to our right-hand side. Now, grade 12s, please, you need to show that it is equal to your right-hand side or your left-hand side. Don't just leave it as equal to 1. Okay, you must give that conclusion. All right, going on to question B of this question. It's saying, hence, show that sine squared 15 degrees is equal to 2 minus root 3 over 4. Okay, so normally with these hence type of questions, you use the information from before, okay? Now, the information that we had before is this thing over here. All right, so what I'm going to do is, before I even get onto this, I'm going to manipulate this thing over here, this previous equation. So I'm just going to write that down, and we've got sine 2x plus 2 sine squared 45 minus x equals 1. Now I can use that whole thing because I have proved it to be true with the previous question, okay? And what I'm going to do here is, because they've got a sine squared on its own, I am going to get the sine squared on its own here. So the first thing I'm going to do is I'm going to take the sine 2x to the other side. And we get 2 sine squared 45 minus x equals 1 minus sine 2x. Okay, then I'm going to divide through by 2, and we get sine squared 45 minus x equals 1 minus sine 2x all over 2. All right, so now that I've got the sine squared on its own, now I need to figure out how am I going to get 15 degrees from this. Now, whenever we get a situation like this, grade 12, you've got to try and use your special angles. And the reason why is because we know what our special angles are if we use them with a trig function. So our special angles are 30, 45, and 60. Now, 45 minus which special angle will give us that 15? Well, it'll have to be 30. So I know that this, so if I just want to make a note here, if I make x 30, that means that this 45 minus 30 will give us 15. And that is what we want. So I'm making x 30 degrees here. So we get sine squared 45 minus 30 is equal to 1 minus sine 2 times 30. Why? Because our x is 30, and that's all over 2. So as you can see now that this here, this sine squared 45 minus 30 will give us 15 degrees, which is that, okay, equals 1 minus, now the 2 times the 30 will give us sine 60 all over 2. Now, it so happens that 60 degrees is one of our special angles. So again, use your fan method, table method, triangle method, whichever one. So 1 minus, now sine 60 is root 3 over 2. And what I'm going to do here, guys, is I'm just going to separate this, divided by 2, okay? Find an LCD here, and our LCD would be 2. So we get 2 minus root 3 all over 2. So that just came from this bracket over here, getting an LCD. Then I'm going to tip and times that, so it becomes times 1 over 2. And then I just multiply top with top, bottom with bottom. So we get 2 minus root 3 all over 2 times 2 is 4. And we've shown that sine squared 15 is that thing over there. All right, guys, I will make another video with the rest later.